Hey everyone! Welcome back to ZoomInData. And this is episode 34 of our KQL Concepts Deep Dive series. Today we shift gears to production reality, how to optimize KQL costs, monitor query health, and troubleshoot slow or failing queries in real clusters. We are keeping everything pure concepts and interview focused. This episode pulls together performance, best practices, and operational wisdom from everything we've covered. Let's get started. Here is our roadmap for today. We will look at major cost drivers, data scanned, CPU time, query duration, materialized view storage overhead. Optimization strategies, filter and project early, use approximate functions, leverage materialized views wisely. Monitoring tools, show queries for duration and resources, query logs for patterns, resource usage tracking, slow query alerts. Troubleshooting steps, identify slow operators, summarize, join, MV expand, missing indexes, bad cardinality estimates, when hints are needed. Production patterns, scheduled jobs, alerting on cost spikes, cost dashboards, regular query review process. This is the operational side of KQL, how to keep clusters healthy and bills reasonable while queries stay fast. Cost drivers in KQL come down to scanned data volume, CPU seconds consumed, long-running queries, and storage for materialized views. Optimization 1. Filter early and project only needed columns, shrink rows and columns before expensive operations. Biggest single win for scanned data. Optimization 2. Prefer approximate functions. Decount instead of count, distinct. Approximately underscore percentile instead of percentile. Orders of magnitude lower CPU and memory at scale with tiny error. Optimization 3. Materialized views. Pre-compute frequent aggregates during ingest. Shift cost from query time to ingestion. Then queries hit cheap pre-AGG data. Optimization 4. Hints and materialize, force broadcast, shuffle when needed, cache repeated subqueries, avoid recompute and bad optimizer choices. Optimization 5. Time-bound queries aggressively, use ago, 7D, ago, 30D, and partition pruning. Modern clusters prune irrelevant partitions automatically. Apply these consistently, and you can cut query costs by 50 to 90% while keeping performance high. Monitoring and observability keep KQL healthy in production. Show queries gives you duration, CPU time, data scanned, user, full query text, your first stop for cost and performance. Query logs, filter for slow queries, duration ems greater than 10s. High CPU, frequent users, spot patterns fast. Resource usage, show cluster resources, ingestion stats, see overall load and bottlenecks. Alerts, set thresholds on slow queries, cost spikes, high CPU queries. Get notified before users complain. Dashboard, visualize top expensive queries, cost trends over time, query patterns. Turn data into actionable insights. Build visibility early. Monitor. Show queries daily. Alert on anomalies. Review top cost queries weekly. Proactive ops beat firefighting every time. Look at this simple flow. It's how you turn raw query logs into actionable production insights in KQL. Start with show queries, your window into everything running, duration, CPU, data scanned, users, full text. Then filter slow, high cost, zoom in on duration ems greater than 10 seconds, high CPU spikes, or massive scanned data. Spot the real offenders fast. From there it branches. Alert, bell icon lights up. Notify the team instantly on thresholds so slow queries or cost spikes don't go unnoticed. Dashboard, graphs of duration ems trends, CPU usage over time, scanned data volume, visualize patterns, top expensive queries, cost drivers at a glance. Clock for slow queries, $sign for cost hogs, CPU meter for resource hogs. These icons make it easy to see what's hurting performance or budget. Build this loop, query logs. Filter, alert plus dashboard, investigate plus optimize. Monitor daily, alert proactively, review weekly, and you catch problems before users complain or bills explode. This is real production observability for KQL. Measure, visualize, act. Troubleshooting slow or failing queries. Follow this systematic approach. Step 1. Show query. Check duration EMS, CPU, data scanned, execution plan. Where is time going? Step 2. Identify slow operators. Summarize, late filtering. Join, wrong flavor. MV expand, too many rows. Pass, greedy on noisy data. Step 3. Check filters. Aware clauses early. Project only needed columns. Late filtering kills performance. Step 4. Cardinality. Large join without shuffle hint. Small side not broadcast. Use hints to force correct path. Step 5. Test partial. Run with limit 1000. Sample 10%. Smaller time range. Isolate the problem fast. Common fixes. Push filters left. Project early. Hint joins. Materialize subqueries. Approximate functions. Debug methodically. Measure first. Fix targeted. And slow queries become fast ones. Production patterns for operational excellence. Scheduled jobs. Use KQL plus logic apps or data factory for recurring reports, daily summaries, exports, automate insights. Cost dashboards. Visualize top queries by cost, per user, trends over time, spot offenders early. Query review process. Peer review before production, estimate cost with. Show queries dry run, prevent surprises. Alerting. Slow query thresholds, cost spikes, high CPU, failed queries, proactive notifications. Documentation. Maintain query library, naming conventions, assign cost owners. Shared knowledge reduces chaos. Build these habits. Scheduled automation, cost visibility, review gates, alerting, docs, and KQL becomes a reliable, cost-effective production engine, not a source of surprises. Check out this closed-loop cycle. It's the heartbeat of running KQL reliably and cost-effectively in production. Start with query. Someone writes or modifies a KQL statement. Then review plus estimate. Peer review the logic, check readability, estimate cost with dry run or show queries, catch issues early. Next deploy. Push to production, perhaps on a schedule. See the calendar icon for recurring jobs. Then monitor plus alert. Track with show queries, dashboards, graphs icon, and bell alerts. Slow queries, cost spikes, failures get flagged instantly. Finally, optimize plus document. Tune the slow ones, add comments, update the query library, doc folder icon, lessons learned feedback into better queries. The loop closes. Optimized, documented queries become the new starting point. This cycle prevents chaos. Review stops bad queries, monitoring catches problems, optimization keeps costs down, documentation builds team knowledge. Build this habit. Query, review, deploy, monitor, optimize, document, and KQL becomes a mature, low-risk, high-value production engine instead of a firefighting tool. Why does this topic matter in interviews? Production operations is a senior-level topic. Interviewers test real-world maturity here. Common questions include, how do you troubleshoot a slow KQL query? How do you control and optimize query costs? What monitoring setup do you use for KQL clusters? Explaining monitoring with show queries, troubleshooting slow operators, cost dashboards, alerting, and patterns like scheduled jobs shows operational skill. It's critical for SRE, platform, data engineering, and cost-focused roles. Demonstrating beyond syntax thinking, impact on cluster health, budget, and reliability, sets you apart. If you can say, I monitor, show queries daily, alert on slow queries greater than tens, review top cost queries weekly, and push materialized views for heavy aggregates, you sound like someone who runs production at scale responsibly. To wrap up, cost optimization, filter and project early, use approximate functions, leverage materialized views, apply hints. Monitoring, show queries, logs, resource usage, slow query alerts. Troubleshooting, identify slow operators, fix late filters, handle cardinality, test partial queries. Production patterns, scheduled jobs, cost dashboards, query review process, documentation. The mindset, measure everything, cost, performance, optimize proactively, document for the team. These practices turn KQL from a query language into a production-ready, cost-aware, reliable platform, the difference between good data teams and great ones. That's episode 34 done. Thanks for spending time with me on ZoomInData. Next in episode 35, Real-World KQL Use Cases, we will explore observability, security analytics, IoT patterns, and more production stories. Homework to lock this in. Explain to someone or out loud. How do you troubleshoot a slow KQL query? Think of one cost optimization trick you've learned, e.g., filter early. Answer this one. Why is monitoring query cost important in production? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 35, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.